That's a claim, Brenda. Can you prove it?
Yeah, I posted a link to a video talking about it.
From the Maine, the drain surveyor. Yeah, really.
Yeah.
Is Bev still here?
I would imagine he just left to go get, as he said, tea, since he didn't respond.
Yeah, Bev's gone for
So
tea.
yes, on a globe Earth with gravity, plumb lines will not be parallel because they will point to the center of the Earth. They will be radial. They won't be parallel.
But surely, if you live on an oblate spheroid, then the center of the Earth would be different depending on where you are on that oblate spheroid. Well, how can it not be? How can it not be, Brenda? Because your surface position on an oblate spheroid from the center of the Earth is different depending on where on that spheroid you are. Obviously, if you're on the equator, you're going to be further away from the center point than if you're at either one of the poles.
Yes, that would be a difference. I don't know if that difference. Excuse me. I wasn't done. But that difference is not. Excuse me. That difference would not be. That difference would not be significant. It might not even be. It might or might not be measurable. I don't even know.
All right. Okay. So that's a claim. Have you got anything to back that claim?
The video talks about that.
All right, well, I'm not going to sit here and watch the video.
Yeah, you're
the one that posted. You're the one that posted the video. So I take it you have seen the video.
The proportion.
So where in this video does it cover the subject that I've just raised? Where
I can address that.
Hang on, can I finish? On an oblate spheroid, depending on where you are on that spheroid, you are at a different distance from the center point of that sphere. Can you tell me where in the video
it would not be significant because of
this
the
is your
size
claim,
of the Earth.
Brenda. This is your claim.
Excuse me.
This is your claim.
Excuse me.
You claimed this. You claimed this before, Brenda.
Excuse me.
Excuse me. Before I asked you to back it up.
No, excuse me.
And now you're claiming it again.
Claiming it again. Excuse me. Now, just listen. Excuse me.
You're excused.
Listen.
Exit stage left, Brenda.
So the point is,
you're excused.
No, go away. So the point is that on a planet the size of the Earth, the
Brenda,
difference is very small.
You are claiming.
That's not a claim.
Again. It is.
That's not a claim. No, it isn't.
It's words from your mouth, Brenda.
No, it's not
a
claim. It's a fact.
Yeah, Brenda.
It's a fact that given the size of the Earth and the amount of deviation from a perfect sphere, the proportional to us, to human size, it's incredibly small.
Okay, Brenda, do you know what the claimed oblate spheroidness is? How much further away from the perfect sphere your oblate spheroid is at the equator? Do you even know that?
It's very small. It's very small.
Do you know how much it is?
I don't know the exact number.
Well, Brenda, how come you're just spouting rubbish?
What is the exact number? What is the difference?
21 kilometers.
Yeah, over 26,000. That's Brenda, a margin of error.
This is very, very small. Kilometers on a 24,000 mile radius.
Yes. Yes, and in proportion, compared 21 kilometers compared to 26,000 is very small.
Brenda, you have nothing to back your claims. You're just saying words, Brenda.
No, I'm not just saying words.
Well, you are.
You are. I told you about proportion.
You posted a video, a link to a video by the drain surveyor. But other than that, you're just spouting words. You can't even say on the video.
No, I'm not just spouting words.
Yeah, you are.
The point is that on a planet the size of the Earth, the difference of 20 miles or so,
21
in proportion, 21, big deal.
Okay.
In proportion to 26,000, which is the circumference of the Earth.
24,000. Brenda, you're not very good with your
doesn't
numbers,
matter.
are you? You're not very good with your own numbers. You don't even know your own model.
It doesn't matter.
Brenda, you don't know. It doesn't matter that you don't know your own model.
Yeah,
how does that not matter?
It doesn't matter. It doesn't
Brenda,
matter because it's
Brenda,
not a
listen
difference.
to yourself.
It's not a huge difference.
Listen to yourself, Brenda. You don't even know the circumference of your own model. You don't know how much the oblate spheroid bulges. What do you mean it doesn't matter?
It's 21 miles. It's 21 kilometers. It's nothing in comparison to 24,000.
Is it miles or kilometers?
It doesn't matter. The proportions matter.
Brenda.
The proportions matter.
Brenda. How's your shoes?
The proportions matter.
How's your shoes?
The proportions matter.
How's your shoes?
So 21.
What about shoes?
And 26,000.
What about shoes? You don't know anything about that.
Because 26,000 is a bigger number than 21. The ground is in the apple's
future.
It doesn't matter in proportion.
That's a direct quote from you. Relating to
you don't know what that was about. You don't understand what I was talking about.
Really? Like I wasn't listening.
What was I talking about, Lev?
Gravity, obviously.
No, I wasn't talking about the shoes. The shoes weren't about gravity.
No, the apple. The apple was the last thing we spoke about, remember? You having a problem keeping up, Brenda?
You were talking about shoes.
The shoes were before the apple, then we spoke about the apple, and then you asked me what it was
about.
You
were talking just now about the shoes.
Yeah. But then I spoke about the apple.
What about the apple?
You asked me what that was about. Well, gravity. The
ground what about it?
The ground was in the apple's future. You would describe gravity.
Yes, that's how it works. Yes.
Okay.
That's how relative.
If that's how you believe it works, then your belief system
it's not
is
a belief.
Up to you. It is
it's not a belief. That's the science.
It is a belief.
That's the science.
Right, so the apple was in the ground's future is a scientific method. You just said it's science, Brenda.
I didn't. You're misstating what I said.
Brenda, can you stop contradicting yourself, please?
I'm not. You're misstating.
No, you are.
You're misquoting me. You're misquoting
Brenda,
me.
You are contradicting yourself.
No, I'm not.
Brenda, step back and listen to what you're saying. You don't make any sense.
The fact that you don't understand it doesn't mean it doesn't make sense.
You can't say that I don't understand because you don't know.
You can't even quote me correctly.
I don't understand.
You can't even quote me correctly.
The ground was in the apple's future. That is a direct quote from you, Brenda. That is a direct quote from you.
So the point is that
no, the point is you just said that I can't even quote
you're just going to keep interrupting me. I'm not going to interact
Brenda,
with you anymore.
You're not making any sense, love.
It is sense. It is. This is relativity. This is relativity. This is how relativity works.
What? One shoe relative to the other shoe.
We're not talking about shoes. We're talking about apples.
Yeah.
Now you're pretending. Are you going to pretend that I don't understand? I'm not following the conversation because you introduced something new.
No.
The way relativity works.
I've been listening to you guys do this for about half an hour now. Okay, I've had.
It hasn't been half an hour. It's been only a couple of minutes.
Brenda, I'm fucking talking.
Who's saying about half an hour? I didn't say anything about half an hour.
This isn't half an hour. So the way relativity works is that all things follow geodesic lines on the curvature of space-time. So the reason the apple falls is because the ground is in the apple's future. It's along the geodesic line, the world line of the apple meets the world line of the ground.
Okay. Well, what if I put a pillow underneath that apple?
What of it?
Then the ground is no longer in the apple's future, is it? The pillow is in the apple's future.
I'm sorry, I accidentally clicked something. What did you say? Please repeat.
Brenda.
I accidentally clicked out of the channel.
Does anybody else want to go at this? I'm bored with her.
So the point is that all things have a world line which they follow, which is the curvature of space-time. Right, which is things are always traveling in the future.
Okay,
you
Brenda,
can't not travel into the future.
Right, hang on.
Right.
You've
So
just brought
so
in.
when the
You've just
apple
brought
hits the
in.
ground,
You've just brought
when
in
the
the
apple hits the
curvature of
ground, it's because when
space-time.
the apple hits the ground, it's because the world line of the apple intersects with that of the ground in the
Brenda,
future.
you brought in the curving of space-time, right? Space is a concept. Time is a
No, it's not.
construct.
No, they're
Yes, it
not.
is.
No,
Yes,
they're
it is.
not.
You cannot
Not.
bend either one, Brenda.
Yes, you can. We can, and we have.
You were saying about the apple falling to the ground. Well, this is a different definition of gravity, isn't it? This is Newtonian gravity. The bending of
No,
space-time is
no.
Einsteinian gravity.
I'm talking
Now,
about Einstein. I'm talking about relativity.
Make up your mind which one you want to talk about.
I've been talking about relativity the whole time.
Right. So the ground being in the apple's future is relative.
Right. The ground intersects. The ground intersects. The ground intersects. The ground intersects with the world line of the apple.
So if I put a pillow underneath the tree, then I've just stopped that intersection. I've just changed your gravitational model.
Well, yeah, you put something in the way.
I've changed your model.
What's confusing about that?
I've changed your model.
No, that's not changed the model at all.
Yeah, it is. The ground is no longer in the apple's future, Brenda. The pillow
because
is
you
in
put
the apple's future. What happens if I pick that apple and it doesn't fall?
What are you talking about?
Well, yeah, Brenda, this to say
what are you
the ground
talking
is,
about? You're just spouting gibberish.
To say the ground is in the apple's future is nonsense, because the ground is not. It is not in the apple's future, is it, love? You can go and pick the apple. You can go and pick the apple from the tree. The ground is no longer in that apple's future. You can put a pillow.
You don't know what you're talking about. You're just talking gibberish, as if you can change things.
I can't go and pick apples from trees. Is that what you're saying?
No, the point is that you're just making shit up. You're just making shit up.
No, Brenda, I've just outlined what a complete and utter knob you are.
Well, you can think that, but you're wrong. Everything I've said is standard science of today. Everything is relativity and how things work in a four-dimensional manifold of space-time. That's how it works.
4 dimensions.
Yes, it's 4.
Don't we just live in 3 dimensions?
No, it's 4.
All right, so you're not in reality.
Reality is 4.
None of what you've said is real. None of what you've said is based in our 3-dimensional physical realm.
No, we live in 4 dimensions. We have the 3 dimensions of space and then the additional dimension of time.
And this is Brenda's world, yeah?
No, this has been relativity for over 100 years. It's 4-dimensional.
Brenda, you're nonsense. You are absolute nonsense.
You can just be confused about it. You can not understand it. Can you stop moving forward in time?
Can I stop moving forward in time?
Yeah. Can you stop moving forward in time?
Time is a concept, Brenda.
No, it's not.
Yes, it is. No, it's not. Forward in time. Yeah. Yes, I can think about what happened in the past. There you go.
Yeah. That's not moving. That's just reflecting. Can you stop?
I went to the past, didn't I?
Moving. No, you didn't.
Well, how the fuck did I know what happened back there then?
You have a memory.
That's in the past.
No, your memory isn't
access whenever I want.
Your memory isn't in the past. Your memory is in the present with you.
You hurt my fucking head.
You can't stop. Yeah, can you stop aging? Can you stop aging?
Brenda, answer me this one, right? The inventor of the first clock, how did he know what time it was?
Time is just a measurement.
How did he know what time it was? How did he know that it's midday to set his very first clock by? How did he know that?
Clocks measure the time between events. So it doesn't.
Who set the first clock?
Have to.
Who set the first clock? How do we know it's midday, Brenda? Who was it that made a concept not tangible? I was going to say physical, but that's not the right word. So tangible. Who was it that made A concept, meaning I can see the sunrise, I can see the sunset. There is time in between those two events.
Yeah,
So
and
who made that tangible? Who said, right, it's now midday, I've invented a watch or a clock. Ta-da, there we go, midday.
Yeah, well, you just define an arbitrary starting point. That's all.
Brenda, you're full of nonsense.
That's how it works.
Absolute nonsense.
You just define midday
time's
when the sun is directly overhead you.
You've just said time is arbitrary. You just set an arbitrary.
No, I didn't say time was arbitrary. I said you defined an arbitrary. No,
an arbitrary.
No, I said time is an arbitrary. You just defined an arbitrary starting point.
Oh, exactly. Time is arbitrary. You just said it yourself.
No, time isn't arbitrary. The starting point is arbitrary.
So therefore, the time itself is arbitrary.
No, that doesn't follow. That doesn't follow.
Can you not see how circular your reasoning is, Brenda?
That's not circular.
The starting point of time is arbitrary, so therefore time is not arbitrary. The starting
point of time. It's just the starting point when you decide to measure time.
So the measurement of time is therefore not arbitrary.
The starting point is arbitrary.
Your head is in knots, girl. Your head is
you
complete
don't understand.
Brenda,
you don't understand.
You can't say that I don't understand. You don't know what I understand.
Yes, you don't understand.
You don't know what I do understand, and you don't know what I don't
you
understand.
Don't. I know that you don't understand hardly anything.
I know that you're talking absolute shite, girl.
This is standard
obvious.
physics for over 100 years. This is standard physics for over 100 years. We live in a 4-dimensional space-time, right? That's standard physics for over 100 years.
Brenda,
we live in 4-dimensional space-time.
Brenda, I've got some advice for you. Pull your head out your ass, girl. Get in the real world.
Do you not agree that you can you stop aging, Lev? Can you stop aging?
Lev.
Can you stop? Well, that's what I see. That's all I know of you. That's all I know is Lev done curving. That's all I know. Yeah. That's the person I'm talking to is
Lev.
The level
is done curving, Brenda. The level is done curving. That's
so. Can you stop aging? Can you stop aging?
Well, no. But that's a biological process. It's not due to time.
And it happens in time, doesn't it?
But it happens in time.
It happens in time.
It's not due to time.
Can you age in a concept?
The difference. That's the
Can you
difference.
age in a concept? Can you
concept can be whatever you want it to be. A concept can be whatever you want it to be.
But you can't stop aging, can you?
No, because it's a biological process. It's not
how can you age in a concept? How can you age in a concept?
A concept can do whatever you want it to.
Is it just a concept that you're aging?
Name and nature. A concept.
Is it a concept that you're aging, or is it
and nature? It is a biological process that I am aging in time.
A biological process that occurs in time.
You don't
time
understand
is
the difference.
Physical.
It's not physical.
Time is. Yes, it is.
It's a construct.
No, it's not. You can't stop aging.
Time. I can go to the shop and I can go and buy, what is it, a pint of time or a gram of time? Or is it a table?
You can measure.
It a table of time? It's a
you
table
can measure
of time, isn't it? Oh, I know times
you can
tables.
Measure.
There's 2 times table. There's 3 times table. Two.
So now you're confusing time with multiplication?
Well, you're talking about time in your table, weren't you?
Why are you confusing
How much
time and multiplication?
I'm not confusing.
Yes, Brenda, you are. You just
you're
did.
You're talking about times table. Time in your table.
No, I'm not. I'm not talking about multiplication tables.
The only time in your table.
That's you not understanding basic words.
If your table is wood, the only time in your table is the amount of time that it took to grow the tree, the amount of time that it took to chop the tree down, the amount of time to manufacture that table.
I can measure that time, can't I?
How can you? The only way
can I measure that time?
The only way you can measure time in a tree is by counting the rings.
No, you can measure time with clocks. You can measure time with lots of things.
So how is your table a clock?
No, I can measure time.
Hang on, wait a second. You asked me if I could measure the time in your table.
No,
right?
I didn't.
I said, yes, you did. Brenda, all
No,
you got
I
to do is
didn't.
all you got to go
I
and do is
asked
go
you.
back and listen. Look, can I finish?
No, I didn't ask
Brenda,
that.
let me finish. And I said the only way you can count time in your table is to count the rings on the tree. And then you started
we were talking about
claiming it was a
trees,
clock.
not tables. We're talking about trees, not tables.
Brenda, pull your head out your ass and
A
keep up
tree
with
is
the
not a
conversation.
table. So
I
you'd
didn't
measure
say the
time.
tree
You
is
would
a
measure
table.
time with a clock.
Oh,
Lev,
Brenda,
you would
you're
measure time
classic.
with a
Oh.
clock.
Do you know how many times I've laughed at you on Nathan's right? And now
I don't care.
Now I'm actually
What do
laughing
clocks?
at you
What
with the
do
conversation
clocks
I'm
measure?
having with you. It's funny. The time
What do
clocks
clocks measure?
a concept.
What? No, they don't.
Yes,
What
they
do clocks measure?
So how do I buy time if it's physical? Where do I go to buy time?
How do you? How can you measure something that's just a concept?
Where can I buy 20 more years for my life, Brenda?
How can you measure a concept?
You tell me, how did the person who invented the clock say, right, now is midday, I set my brand new one in the world, only one ever, 12 o'clock, bang, there we go. You tell me.
Well, he
You're the one that
defined.
says it's physical.
Well,
You're
you
the
have
one that
to
says
actually
it's
allow
tangible.
me to answer you. You have to actually allow me to answer you. So the answer is he simply defined midday as when the sun was directly over his head. That's how he did it. That's how he did it. Midday is when the sun is directly overhead. There, done.
I'm clipping out. I keep clipping. Hang on, let me drop and come back again.
Turn up the radio. It's a shoe. How much time is in your shoe?
That's not the point.
Nah. Why not?
You don't understand. You're not being able to understand the example. Doesn't mean it was false.
No. What if we do understand? It's just.
But
stupid.
you don't. What was the shoe in reference to?
The shoe was in reference to a really cool Corona song.
No, it wasn't.
And it had your face on it going, shoe.
That's not what it was about.
I thought it was pretty funny.
I don't care what you think.
Well, that's frickin' clear.
Right. So
but
the
it
shoe
would matter. It would matter if I thought the Earth was a globe, correct?
The shoe was about whether or not we could do scientific experiments on man-made objects.
It would matter if I thought the Earth was a globe, wouldn't it?
You would still be wrong.
I would still be wrong if I thought the Earth was a globe, correct?
No, you would still be wrong about the shoe, even if you believed in the globe. So what was the shoe? What was the shoe about?
What is the shoe then?
No, it was a hypothesis. It was a hypothesis, wasn't it, Brenda? You hypothesized a shoe, and therefore it was a shoe.
No, that's not what it was.
It was to do with the scientific method, anyway. It was all to do with the scientific.
It was to do with the fact. It was the fact that you can conduct experiments on man-made
shoe,
objects.
Therefore, shoe.
No, that's not what it was about.
Right. Okay.
You don't understand.
Yeah.
It was about Nathan. It was about Nathan lying about the scientific method. Yes, I know. You don't want to know that it was about Nathan lying about what the scientific method was.
Well, do you know, Brenda, right? My conversation with you for the last, what was it, 20 minutes maybe? I don't know. I haven't really been counting, right? I haven't got a watch to keep time, so I must go down the shop to buy what is it,
so it wasn't really a conversation because you just talk over me all the time.
Because you just absolute waffle, girl.
No, I didn't.
Bullshit
Not at all. Your
Brenda,
incredulity doesn't mean it's false.
Do you know how many times you contradicted yourself, girl?
I didn't contradict myself at all.
Well, go back and listen to this after because it'll be going up on YouTube.
That's fine.
And absolutely hilarious. The amount of times you contradict yourself.
You think it's ridiculous that we live in four-dimensional space-time, but that doesn't mean it's false.
Hang on, Brenda. You just said it. I think it's ridiculous that we live in four-dimensional space.
Space-time.
No, that's not me, girlfriend. You've just described yourself.
We live in four-dimensional space-time.
Oh, so it's not me that lives in four-dimensional space-time, like
we
you
all
just
do.
asserted.
We all do. I didn't say that you.
No.
I didn't say that.
Yes, you did.
You're lying. You're lying.
You said I believe that I live in four-dimensional space-time.
Yes, we do.
No, I don't believe that at all. So you have just
It's not what I said.
Yet again.
That's not what I said. That's not what I said.
Brenda, you've just contradicted yourself yet again.
No, I didn't. I didn't.
Why can't you keep up with the conversation, Brenda? Are you mentally deficient?
You're misquoting me.
Do you take pills?
You are misquoting me.
Stopped you from getting to the hospital
this is just
to get
you
your medication?
Being sick. So
Brenda,
the thing is that we live in four-dimensional space-time.
No, this is your belief. This is your assertion.
You think that that's funny.
You have
that
no
you
proof.
think that that's ridiculous and that you can't understand
Brenda.
that doesn't mean it's not true.
This is an assertion of yours. This is an opinion of yours that
it's not an opinion.
Prove.
It's a scientific fact. It's not opinion.
On.
So where is your citation? Where is, as QE would say,
it's the whole of
where is your cowbell?
The whole of science since Einstein.
So give me a citation. Give me something to read.
All of science, all relativity since Einstein.
Brenda, you are mental, girl.
Yeah, you can say
absolutely
that relativity,
off your chuff.
Yes, you can say that relativity is nonsense. You can disbelieve it, but it's a fact.
Brenda,
it's not an opinion. It's a fact.
I don't have to believe it. It is your opinion.
Yeah, you can disbelieve it all you want.
Until you give me a citation, until you tell me something that is tangible, and until you tell me where I can go and buy time by the pound or by the pint or by the litre.
Nobody's claiming that you can buy time by the pound.
You said it's physical.
Yes, it's physical. Yes. That doesn't mean you can. That doesn't mean it has weight. That doesn't mean it has weight.
So something that's physical doesn't have weight.
There are things which are physical which do not have weight. Yes.
Such
as light.
Light. So light's physical.
Yes, light is physical.
Well, if we believe your scientists, right, they have invented solar sails. You know what solar sails are?
Yes, I do.
Yeah. So this would lead you to believe that light is physical, wouldn't it? That
light is physical because it's a part of the physical world.
Yeah, Brenda, who actually knows what light is? Is light a particle or is it a wave?
It's a wave packet.
A wave packet?
Yes.
A packet of waves, like a packet of crisps,
yes.
Like a pound of sugar, like a litre of time.
No, exactly like a packet
Brenda,
of, I don't know what you mean, a packet of crisps.
You know,
well,
are you American? Are you American?
This is physics.
Are you American?
And it has been physics for a long time.
Are you American?
Light is a quantum of wave energy.
Are you in America?
Yes.
Yeah. Oh, chips then, not crisps. Chips to you. A packet of chips.
Whatever.
A litre of milk. A pound of time. Please,
light,
Mr. Wholesaler.
Light is a wave packet. It is a quantum of wave energy. That's what light is.
Okay, Brenda. You got citation? You can prove this, or is it just words? It's just words from your mouth.
No, this is any high school physics
Brenda,
book will tell you.
This is just words from your mouth, love.
Yes, it's words from my mouth, but that doesn't mean that they're wrong.
The same as the time in your table. The same as the ground being in the apple's future.
Yes.
The same as all the other bullshit you say, Brenda.
It's not bullshit.
It's tiring.
This is standard physics.
Brenda.
This is standard physics. We live in a 4-dimensional world in which things follow on world lines, which is a space-time world line.
Hey.
And light comes in a quantum of energy.
No, not a packet anymore. It's a quantum.
That's what I said. Quantum and packet mean the same thing. Quantum means a discrete unit. They mean the same thing. A quantum is a discrete unit of something. So light comes in discrete units of waves.
I take your word for this now, do I? You can't actually give a citation for this. Well, Brenda,
you do the work. Look it up. Look up the word.
Claim, girl. You're the one that's made the claim.
No, I don't have to do your work for you.
But you
look up the word quantum.
You have made the claim. Now provide the citation.
No, I don't have to.
Yes, you do.
I don't have to.
You've made a positive claim, Brenda. If you if you can't cite your own claim, then your claim is just an opinion, and it is worthless.
It's not an opinion.
It is an opinion unless you can cite it. We'll cite it.
And that's all of physics. Any physics textbook from the last 100 years.
Girlfriend, cite your claim.
I don't have to.
Yes, you made a positive claim. It is up to you to provide a citation to back your positive claim.
My citation.
So off you go, run along, put your shoes
my citation
on,
is all of physics.
Ground, go and get a pound of time and get a citation while you're out, love.
Time doesn't come in pounds. That doesn't mean it isn't physical.
Bev, are you back?
Yeah. I'm just looking at world lines, Brenda. Fantastic, aren't they?
Do you know that
a one-dimensional line or curve? I'm reading here.
Yes.
Yeah. One-dimensional.
So do you understand?
Line or curve.
Yeah. So what?
Do you have to imagine that one-dimensional line or curve?
It's a description.
Yeah. What's one-dimensional? I mean, I know what two-dimensional is. Can you explain a one-dimensional line?
One-dimensional. That would be a line. It's a description.
Yeah.
It's geometry, right?
What, one dimension?
Line in geometry, lines are one-dimensional, right, Bev?
Yes.
Yeah, there you go.
And
what?
A one-dimensional line. Like, like
lines
imagine
lines are one-dimensional, Bev.
Yeah.
Congratulations.
Two-dimensional line.
No,
you'd be able to look
at
a two-dimensional. Well, you would be able to look at a two-dimensional line, wouldn't you?
There are no two-dimensional lines, Bev.
Are there not? Not even when you draw it.
Lines are not two-dimensional. They are one-dimensional.
Okay, in the concept.
Planes are two-dimensional, Bev. A plane is two-dimensional. A line is one-dimensional. And a point has no dimension.
Length without breadth, right? Geometric term for a line.
That's geometry. You understand?
Yeah. Yeah, so a one-dimensional line or curve is what a world line is.
Yeah.
Yeah. Okay, so that is what you were using to explain four dimensions, was it?
No, it explains. It's part of relativity theory.
Yeah.
Yeah, it's part of the theory.
That where you use a one-dimensional line to express a four-dimensional time frame.
No.
No?
No, you got that wrong.
Okay, so go on. What's a world line then?
A world line is a one-dimensional line. It's a description. It's a description of an object's motion through space-time.
Okay, these we are talking world lines in special relativity, right?
Yeah.
Okay. And then what I'll do is
It's a
I'll show you
description. It's a description.
Minkowski space,
Right?
Yeah.
You understand what a description is?
Yeah. Okay, here you go.
Right.
I've
So
marked
it's
out a
a
few bits there
description.
so everyone can see what world lines in special relativity. And it says world lines or freely falling particles / objects are called geodesics in special relativity. These are straight lines in Minkowski space. Do you want me to show you what Minkowski space looks
Yes.
like?
Yes.
Right.
And Minkowski space is curved space-time.
But it's what Minkowski space is. You know how it's shown Minkowski space. I get that. So, just for anyone who doesn't.
So you're just backing up everything I've said for the last half hour, right? That world lines, objects are following a geodesic in four-dimensional space-time.
Yeah, a geodesic, which is a straight line depicted on a graph, just like that. Minkowski. Yeah. So they represent 4 dimensions on a 2-dimensional graph with a straight line that is actually 1-dimensional.
What about it?
Well, I was just in case anybody didn't understand. Does that explain it to everybody better than what Brenda's done?
Well, what you're showing is the world line of a photon. The world line of a photon is a 45-degree angle on a Minkowski diagram.
Yeah, how is it? How is it work?
Nothing else can follow. Nothing else, because we can't travel at the speed of light, so our angle would be less than that.
Properties of space and time in a special theory.
Yeah, everything. Thank you for backing up everything I've said. Objects follow world lines, which are geodesics, as described on a 4-dimensional space-time Minkowski space. That's everything I've been saying over and over.
Two-dimensional graphs.
Thank you for backing me up, Bev.
Events as happening in a universe consisting of 1 space dimension and 1 time dimension. So that's what a Minkowski graph does.
You can do that. You can do that. Yeah, they just collapse the space dimensions into one axis, and the time dimension is the other axis. Photons, in that kind of a diagram, photons travel at the speed of light, which is that 45-degree angle that you see there. We can't travel at the speed of light.
Yeah. Yeah, that's fine. If you have to use a 2-dimensional graph to show a 1-dimensional line to explain a 4-dimensional space-time curvature thing,
you just collapse.
That all takes place in a theoretical universe.
Yeah.
No, this is a description.
Absolutely ridiculous.
The universe isn't theoretical.
No, your
universe. The description is theory.
Yours is a belief system. It's imaginary. It's in your head.
No, it's not imaginary.
Of course
it's not imaginary.
It's a belief system, Brenda.
No, it's a theory. It's a scientific theory. A scientific theory is not
in a belief system.
No, I don't. I live in reality.
You believe you live in 4-dimensional space-time continuum.
This is a description of the reality that we live in.
Oh, the reality you think you live in, Brenda.
Well, it's not a belief. This is how reality is.
Well, I see. We deal a lot more in reality around here.
You don't understand parallel lines, Bev.
Brenda, you can't say that he doesn't understand. You can't claim you can't claim that anybody doesn't understand.
Yes, I can.
Because it's all right.
You don't know.
You don't know. Brenda's going to explain it. Brenda's
going to explain it.
Yeah.
Really?
I'm going to explain that Bev doesn't understand that plumb lines are not parallel.
Why? How?
Because you can measure them, and they're not parallel.
How would you do that, Brenda?
You would measure them.
How? How would you measure them? Tell me, please. Method.
You would make a series of observations. You would construct 2 plumb lines a certain distance apart, and then you would measure them to see if they are parallel. And as it turns out, they're not.
Explain the measuring process, please.
I don't know. You just
Okay, so
go
you're
about doing
words
it.
again.
It doesn't
You're
matter.
spouting words again. Brenda, I've got one for you. Brenda, I've got one for you. But how far apart do those 2 plumb lines have to be before they actually start showing a divergence from plumb? And is the divergence from plumb divergence from each other, or is it divergence from a central plumb line, a third plumb line, essentially, that you would have to put in to measure the divergence from?
The reason is that plumb lines
I didn't ask for a reason. I didn't ask for a reason.
The center.
Plumb
lines point to the center of the Earth,
Brenda,
and therefore they are radial. They are a radius, and they point to the center of the Earth. So therefore, they're not parallel.
Believe reason. I asked, at what point does this divergence become a measurable, tangible, observable thing?
It depends on your ability to measure it.
Well, Brenda, there must be a certain point
it depends on your equipment.
Well, what equipment are you using to measure your make-believe divergence of plumb lines?
I don't make the measurements. I'm not a surveyor, but surveyors do, and they can. And Bev was in a hangout with MC Toon, and MC Toon humiliated Bev and showed him how wrong
No, he did not. MC Toon spouted the same bullshit rhetoric that all of you do.
It's not rhetoric.
No,
These are
it is rhetoric.
These are facts.
DP, just a minute.
From the same
Brenda.
He humiliated you. He humiliated you. Showed you to be the utter fool that you are.
Brenda, he's
that
not
you
a
can't
fool.
understand
Brenda,
the difference between plumb and parallel.
Brenda, if you can't have a decent conversation without
I just want to be able to finish a sentence. You constantly interrupt me.
Brenda,
you constantly interrupt me.
Brenda,
so why should I respect you?
I don't care.
Yes, you don't care. Then this is what happens when you don't care.
You're disrespecting. It's Bev.
I'm disrespecting you because you just constantly interrupt me.
Brenda, can I just put in here? DP,
that's because I've got no respect for you, Brenda.
Let's have a go at this. Bev. Brenda, right. You say surveyors have measured this. Can you name a surveyor, please?
I posted the link.
Put a name to that person, please, and then we'll look into it. I mean, but I need to know who you are getting your information from that says they have measured plumb lines, because you obviously don't know how to do it or anything. You don't know the method or whatever. So you're obviously not really good. You're just getting this information from someone. Now, who has told you that they have measured that plumb lines are not parallel?
There you go. There's the link to the Maine surveyor.
Right. So him.
He shows that plumb lines are not
and you personally are willing to take on what this person says. Yes, you are saying that this man has definitely done what you've just claimed he has done. Yes, or he's just made a video. What you doing? Which one is it, Brenda? I know he's made a video.
And there's the slide. There's the slide from the measurement.
Yeah, that's great, isn't it? Who have you been over and checked this out with?
Yeah. Do you understand what that's talking about?
Have you been to a team meeting and made sure that that's okay? Have you?
It shows that plumb lines are not parallel, and this is a real world measurement,
doesn't it?
Yeah, picture paints 1,000 words.
Illustration. The picture is an illustration of what he did.
Is it?
What was done?
Is it, Brenda? Really? That is an illustration of what this man did. Yes? You've watched the video and you know for sure that this is an illustration of exactly what that man did. Trilly?
So do you have a problem with that? Do you have a problem with this?
I'm just
What
trying
is
to,
your objection?
I'm just trying to
No,
make sure,
what is your
Brenda.
objection?
Just trying
What's
to
your
make sure.
objection?
Are you okay
What's
with
your
this?
objection?
I'll go over it in a video.
What's your objection to it?
You can't see a problem with it?
No, I don't.
Okay, fine.
What's your
That's
problem
fine.
with it? What's your problem with it?
It's hilarious, but
you don't have it.
I don't.
Well, you
I
can
don't,
think it's
what?
hilarious,
Sorry?
but what is your problem with it?
What?
What's your problem with it?
Can you see that bit in the middle?
Yes.
Them two dotted lines. What are they?
The two dotted lines are horizontal line A and horizontal line B.
Okay, and then imagine you've got plumb line A and plumb line B. Yes?
Yeah.
Right, okay. Now, is the plumb line at B perpendicular to the horizontal at A?
No.
Oh,
it's perpendicular
so
to the horizontal
vertical and
at B.
horizontal aren't perpendicular then, are they not?
The plumb line is perpendicular to the horizontal line at B.
Mm-hmm.
It's perpendicular, right?
But it's not perpendicular to the horizontal at A.
That's correct. That's the point.
So,
they're not parallel, are they?
How many plumb lines could you put on a horizontal?
So they're not parallel. The point is that they're not parallel.
Can we count them, Brenda? You tell me when to stop. One.
Bev.
Two.
Bev.
Ooh,
Bev.
Three. I got past two, Brenda.
Is the plumb line, is the horizontal line at the plumb line at B, is it perpendicular to the horizontal line A?
It should be, yes. It doesn't appear to be on that drawing. Well, it's not on that drawing.
Right. Yeah, it's not.
No,
but
it's
the
not on that
drawing
drawing.
represents real world measurements.
Does it?
That's the real world.
And that was done. That was definitely done by the Maine surveyor.
Yes, and that shows that they were not parallel. Right.
Right. So that shows that when people say vertical and horizontal are perpendicular, there should be a proviso that comes after that says only at one point.
Yeah, that's what it means.
No, it's not.
That's what perpendicular means. Perpendicular means it's perpendicular at a point.
Really struggle with Euclidean geometry. Fundamentally, with
what
I don't
you are
trying to explain. I can understand why you
don't struggle with it at all.
Mentally, trying to understand the concept of reality. Yeah,
you're the
must
one
be hard work.
Who can't understand this. Bev, the plumb line at B is perpendicular to the horizontal line at B, right?
Yeah,
and the plumb line
horizontal
at A
and vertical are perpendicular to each other. That's why they're just called perpendiculars, aren't they?
Well, at B.
Well, no, the horizontal and vertical are perpendicular.
At A, it's a different horizontal.
I don't think it says that at A is a proviso anywhere.
That's exactly what it says. That's exactly what it says.
What about
at station A? At station A, it says that there's a plumb line and a horizontal line, and they are in perpendicular relation to each other, right?
Yeah, horizontal and vertical are definitely perpendicular.
At occupy station A.
All times, yes.
No.
Yes.
At position A.
No.
And at position B, there are two different horizontals and two different perpendiculars.
What, have you got any citations or anything?
This is the real world. This is how it works.
Just what you say is the real world.
Bev doesn't
no,
do
this is a real world measurement.
Brenda,
this is a real world measurement.
Bev.
What is a real world measurement, Brenda? You don't even know what measurement they've done, do you? You don't even know the method that they've used.
This is a real world measurement.
What is the real world measurement you are talking about?
At A, there's a plumb line and a perpendicular, which is perpendicular to horizontal line A, and at station B, there's a plumb line which is perpendicular to horizontal line B, right? And they are different. Therefore, they are not parallel.
They are not parallel.
Correct.
Um,
And they're both plumb lines, and they're not parallel.
can you explain that geometrically?
I just did.
Really?
You have two plumb lines. You have two plumb lines at two different stations, station A, station B. You construct a plumb line, and that they are perpendicular to horizontal line B and horizontal line A, and they are different. They are not parallel. This is the real world, the world we live in on Earth.
Yeah, where horizontal is a straight line.
Where, yes, horizontal is a straight line perpendicular to the plumb line at point station B, at that point. But it's a different horizontal line at station A. It's a different horizontal.
Yeah, which would eventually intersect with a horizontal. Is that what horizontals do in your imaginary? Like, have you ever drawn a graph with an X and a Y axis?
This is on the real world.
Yeah.
This is not on a graph. This is the real world.
Yeah, we use Cartesian coordinates to express coordinates in reality, don't we? Or do you not?
Well, you can use spherical coordinates on a planet.
Well, yeah, really?
Yes.
Spherical coordinates. Can you give us an example of one of them for us, please?
You're the geometry guy. You don't know what spherical coordinates are?
Oh, well, why would I want to know what spherical coordinates are?
Because you live on a planet.
Says who?
It says reality.
Right, well, isn't that what we're trying to do here, though? We're trying to decide. You've already decided, have you? The shape.
Because if we lived on a plane,
Yep.
then plumb lines would be parallel. Plumb lines are not parallel, so we do not live on a plane.
Perpendicular to horizontal, aren't they?
It doesn't matter. If we lived on a plane,
yeah, if we
the plumb lines would be parallel.
There's a canal.
The plumb lines are not.
The
plumb lines are not parallel. The plumb lines are not parallel. Therefore, we do not live on a plane.
That's a bit repetitive of you.
Because you don't understand it.
You learnt that from Rumpus.
You don't understand it.
You say you don't understand that. Did you learn that from Rumpus, or was that somebody else that taught you how to do that one?
So, do you now understand
that vertical and horizontal are perpendicular? Yes, I do. Fine.
There's a perpendicular. The plumb line is perpendicular.
Yep.
To horizontal line B at station B.
Yep.
And it's perpendicular to horizontal line A at station A, but they are different perpendiculars, and they don't intersect.
Right.
I mean, they're not at right angles with each other.
So
they are at
not
94.
Not all.
94.
Not always.
Degrees, 4 seconds. Right.
Yeah. Vertical 94. And horizontal aren't always perpendicular. Is that? Do we need a new definition for vertical and horizontal?
No, we don't.
So all of these ones that say in the dictionary or anywhere, it says perpendicular. And then approximately right angles to the horizon. That's vertical, obviously. Perpendicular and plumb are generally used to specify an angle of precisely 90 degrees.
Yeah.
Yeah.
Yeah, that's what the image shows.
Yeah, and perpendicular needs two straight lines, doesn't it?
That image.
Yeah, can I get a confirmation on that? Yeah. Perpendicular is two straight lines, isn't it, Brenda?
No, perpendicular is a 90 degree. No, perpendicular is a 90 degree angle.
Yeah.
To a defined point.
Yeah, and all right angles are equal, right? All right angles are equal.
Yes, and yet these right angles don't add up.
What?
They don't add up.
They don't. Sorry?
They don't add up.
Who doesn't add up?
They are greater than 180 degrees.
So is that a straight line has more than 180 degrees?
No. So the sum of the angles A and B is greater than 180 degrees.
Some of the internal angles of the triangles within
No.
what he's just done there is greater than 180 degrees? No?
No, of the plumb lines, the angles A and B add up to be greater than 180 degrees.
Okay, so the triangles there have an internal angles of 180 degrees.
That's not what I'm talking about.
It is, isn't it? Like it's
it's not what I'm talking
about. Yeah, of course it is.
No. We're talking about the angles A and B in the illustration I posted. The angle B at station B and the angle A at station A is greater than 90 degrees. They add up to more than 180 degrees. If they were parallel, they would equal exactly 180 degrees. Therefore, they're not parallel.
Brilliant. So, your basis of all of this relies on the fact that some dude has done a video on YouTube that you cite saying he has actually measured more than 180 degree internal angles on a triangle.
No, it's not based on some dude. It's not based on some dude.
Is it? It was. You just posted it before. The Maine surveyor was your dude, your man, Jeff.
Yeah, that's an example. Jeff. It's not just some dude.
You've had a word though, haven't you, with him? And he's told you this is rock solid, Brenda. Absolutely rock solid. This
is all engineering. This is all surveying. Yeah. All engineers. All surveyors.
Surveying. Not plane surveying, surely.
Yes, it is.
No, plane surveyors.
All of them.
Plane surveyors assume a flat plane, don't they?
So this is all observers will record that if you construct a plumb line at one point and another plumb line at another point, then the internal angles of those plumb lines will be greater than 180 degrees because they are not parallel.
Okay, so what sort of a distance do you reckon he did measured that at?
Well, it doesn't matter what the different distance is.
It does, because it
doesn't.
Yeah,
it doesn't matter.
Brenda, yes,
it doesn't matter.
Listen. We're trying to measure a water level test. Now, the water level...
No, we're not.
Yes, we are.
We're not trying to measure...
Right, yeah,
we're not.
Because
we're not.
Brenda, we are laying off a horizontal baseline. We're calling that the water level.
No, we're not.
Right?
No, we're not doing that.
Then we can
That's not what we're doing.
Then we can get 2 theodolites or levels or dumpies or whatever. I've got one. Spot on's got one. We can meet at the side of the canal. We can get a water level there, right? Now, you say that the horizontals that both our tools have will not sight each other, right? You say they will sight above each other. Now, what sort of distance could we get in order to measure that distance?
It depends on your equipment, on how
when I say measure, I mean actually measure with a stick to measure, right? Not just messing about with angles and some sort of...
It depends on your equipment, right? It would depend on how accurate your equipment is. Yeah. Over a greater distance.
Okay, let's say we've got the best equipment. How far apart would we need to do that?
It doesn't
Brenda?
matter.
It does.
It doesn't matter.
Yes, it does.
No, it doesn't.
It does, because you're talking bollocks.
No, I'm not.
Yes, you are. You're definitely talking absolute
This is
shite.
Bev.
Yeah.
This is how things actually are.
It's not.
When if you have 2 points.
Just saying that is not convincing yourself, and you are definitely not convincing anyone else here listening. Right?
Well, my inability to convince you.
The first thing about surveying, right? Now, you are claiming that professionals that do a job that you know nothing about do something that you also know nothing about.
None of that matters.
You are claiming you know everything about it.
No,
Isn't that strange, Brenda?
I'm not claiming to know everything about surveying. I am claiming that when you construct a plumb line at 2 different points, those plumb lines will not be parallel. And that's all
you are claiming that because you've watched a video. Did you? I don't think you may have read the title of a video that somebody's made. And now that man...
It doesn't matter.
That man takes a very good topic, like, and he goes, I tell you what I'm going to call myself. I'm not going to be a professor. I'm going to be a surveyor. So this character makes a
all
pretend...
besides the point.
Doesn't he, Brenda?
This is all besides the point.
Do you know the acting game that goes on the YouTube?
If you construct a plumb line at 2 different points, those plumb lines will not be parallel on Earth.
Says Jeff, the Maine surveyor.
Says all surveyors and all engineers.
Don't jump everybody.
All observers. Yes, all observers.
So you
are
making a claim. Yes?
On Earth.
Brenda, definitely.
Yes. Listen, stop interrupting me. Stop talking over me.
Oh, it's rude.
All observers on Earth will show or be able to measure that 2 different plumb lines at 2 different points will not be parallel.
Okay. So my water level test will definitely show that the water level rises in between the 2 bits, right? Because the horizontals rise to that point, so we'll definitely be able to show that with my water level test. Now, Nick earlier said that. No, you've just said it. I mean, you don't realise what you're saying, but you have just said that geometrically. Yes, you have.
No, I haven't said that.
Have,
I don't know. You have. Your water level test might not be accurate enough.
Over 2 miles.
You've done this 2-mile water level test?
I know of a... We're just trying
You haven't done it.
We're trying to work through it. No. So what would it prove then, Brenda? What would happen? What would we expect to see?
You haven't done it.
What would we expect to see?
The water...
How high would the hump in the middle be?
There's no hump in the middle.
It's horizontal then. Thanks.
No, there's no... It's not horizontal. The Earth is curved.
Okay, so... But there's no...
You're a flat earther and you think...
There's no hump in the middle of a curve.
Hump?
Yeah.
Right.
Yeah.
Right, there isn't.
There isn't.
Not on a globe.
On a curve.
Not on a globe.
It's flat.
There's no hump in the middle.
Yeah, that's horizontal.
It's not flat.
We'll call it horizontal,
curved.
should we?
It's not flat.
Should we call it horizontal? Should we call it horizontal? And just imagine it curves.
Do you understand how spheres work?
Yeah, they have a big curve in them.
If I'm at the top of a sphere of a ball,
yeah, balancing.
And another person,
circus act.
No, just a minute,
you do juggling? I can imagine.
Stop! Don't try not to get distracted.
Big shoes on the top of a ball.
Don't get distracted by the shiny object. Don't get distracted by the shiny object. If you are standing at the top, if you're standing at the top of a sphere, right, and somebody else is standing a ways away from you, is there a hump in the middle?
Sorry, I can't. I'm
I know.
Imagining you rolling about on a ball.
You got distracted by the shiny object. So, if you're standing on a large sphere,
okay,
right, and somebody else is standing a ways away from you, is there a hump?
Do they have their own sphere they're standing on?
No, they're standing on the same one you are.
What?
Is there a hump?
How could they be standing a ways away from me? We'd roll
off.
Is there a hump? Like, wouldn't we have to be really close, balancing together?
Is there a hump?
What?
Is there a hump?
I don't know. You'd have to show me what this looks like. I can't imagine how
you can't
stand on a ball with somebody else.
Right. Right. You can't imagine standing on a sphere. Yeah, you can't imagine.
I can imagine you standing on a sphere, juggling.
But can you imagine you standing on a sphere?
Balancing like you, juggling.
No,
I could do.
It's a really large one. It's really large. It's huge. You don't have to.
You'd have to be on the top though, wouldn't you? Because it's a ball. You'd still have to balance, wouldn't you? Because it would roll about all over the place, wouldn't it?
If it's really big, somebody could stand a ways away from you without falling off.
But why? It would
it's
roll,
really, really big.
Yeah, but it's a ball.
No,
it would roll, wouldn't it?
No, it's a really, really big.
Do, though. It doesn't matter how big it is. If you put an uneven weight balance on one side of it, it'll roll that way, won't it?
Imagine yourself on a sphere.
Yeah,
Yes.
I'm trying to imagine it.
Try.
I keep falling off.
Can you do that?
Move me away from this.
Can you do that?
The top of it, I'll fall off.
Can you do
it
that?
will roll.
Why are you
Be like
avoiding this?
log rolling or something like that.
Why are you
Spot
avoiding
on.
this?
Why am I avoiding what, Brenda?
Why are you avoiding this?
Why am I avoiding what, Brenda?
Yes, like this right now, what you're doing right now. Why are you avoiding?
Yeah, this is a brilliant tactic.
Why are
isn't
you
it?
avoiding?
I'm sure you look really smart at this point.
Why are you avoiding?
What am I avoiding, Brenda?
The illustration.
Which illustration? Have you put an illustration up somewhere?
What I was talking about, imagining yourself on a sphere.
Did you illustrate that imagination?
Why are you avoiding this now? You're doing it again.
I'm looking for it.
You're looking for what?
The illustration.
Just imagine yourself on a sphere.
Yes.
Okay. Imagine somebody else a bit of a ways away from you on a sphere.
I can't. Like, that's really
You
tricky.
can't do that.
We're not
You can't do
circus
that.
zodiacs.
You
My
can't
balance.
do that.
I'd
Huh?
have to get it really. I'd have to practice that. It takes teamwork.
Why are you pretending to not be able to do this?
I'm living in reality, Brenda. That's a pretty circus trick, that.
No, it's not reality. I asked you
It's
to
not
imagine
reality.
yourself.
Okay, fair
Right.
enough.
I asked you to imagine yourself on a sphere. That's not reality.
Yeah. And I'm telling you that if you move away from the center balance point, then the sphere will start rolling.
No, this is imagination. Is not real.
Yes. Okay, so is it fixed then? Is this ball fixed?
Just imagine yourself on a very large sphere.
The sphere isn't going to roll. It's fixed.
No, it's not going to roll.
Okay. So the further I walk away from that top point, the more of a slope there is, it's going to turn into a slide. No. Okay, I'm right at the top of the sphere. Stood on it.
Yeah.
Yeah.
Yeah. Half an hour to get you to imagine this. Half an hour.
No, I've been looking at it all the time. I'm still imagining it now. I'm a sphere. I'm sat on a sphere that doesn't move. And
so is there a hump? Is there a hump between you and somebody else on the sphere? Or does the sphere fall away from you at every point?
It's like a slide, isn't it? Yeah, it's like a slide. You could slide up it. Yeah.
Right. There's no hump, is there? There's no hump.
What do you mean there's no hump? Yeah,
you're the one that said there was a hump.
It's like a massive curved surface all around me.
Yeah, but there's no hump, is there?
Wait, Brenda, what are you talking about?
I'm talking about the hump. Where is the hump?
The camel?
No, the hump. You said there was a hump. Where is it?
In the water level. Yeah, because that's what we're talking about here. Water level.
No, we're not.
If there's no hump, it's horizontal. That's what the water level does. It finds its own equilibrium. So it's all the same level.
So you said there was a hump. Where's the hump?
You said there was a hump because you had intersecting horizontals.
No,
I
didn't.
Yes, you did.
No, I didn't.
Yes, you did.
No,
you showed us a picture of it, Brenda. You showed us a picture and said the Maine surveyor, Jeff, has measured parallels. Plumb lines are not parallel. And the reason he's done that is because the horizontals intersected at a point. Now that point is higher than both of the other two horizontals start point.
Yeah.
Yeah. So you have said there is a raise in between the two horizontals.
No, it doesn't show that.
It does, geometrically. It shows it. You drew the lines.
No, it doesn't.
And they intersected there. That point of intersection was not on the line, was it, Brenda? So you have confused everyone by saying that horizontals intersect. Which they obviously do not.
But they do.
They can't, can they?
But they do.
Really?
Yes, they do. You say they can't, but they still do.
You say
because that's
they just
because
have to.
Not because they just have to, but because on a spherical Earth, plumb lines are not parallel. That's why they intersect.
Can we say in reality? Do you want to try in reality?
In reality, on Earth, plumb lines are not parallel, and a horizontal from station A and from station B will intersect above line of sight.
Oh. How much practical use of geometry have you ever had? Ever? I'm talking...
What does that have to do with anything?
Have you ever used a level? A site level? A theodolite level? Well,
a carpenter's level, yes.
Oh, you have used a carpenter's level. Any other? Have you ever used a water level?
No.
No. Okay. You've used a spirit level, though.
What does that have to do with this?
I'm just checking
your
practical. Have you ever used a plumb line?
No. Well, yes, I've used plumb lines. Yes.
Okay. What was it to do?
It was when I helped my family. We built a house, and we used plumb lines and carpenter's levels to construct the house.
You used the levels to construct the house.
We used the levels in the course of constructing the house. Yes.
Okay. How did you use the plumb bob? Just as a matter of, when
to make sure the concrete was level.
The concrete.
And the concrete and then the walls. Okay. Yes.
So you used the plumb bob to make sure the concrete was level.
They were to make sure they were vertical. Yes.
Okay. The concrete. Yeah.
To make sure the walls were vertical.
Oh, right. Where was the concrete? Did you have concrete walls?
No, we had a concrete floor.
So you used the plumb bob to make sure the concrete was level?
To make sure the walls were level.
Oh, no, not the concrete.
The walls were vertical, I'm sorry.
Okay. Yeah, it's a good job you had vertical walls.
Yeah.
So what did you use to make sure the concrete was level then?
A carpenter's level.
Really?
Yeah, you just flatten it out.
You didn't level the shuttering beforehand?
Didn't level what?
The shuttering for your concrete work.
I don't know what you mean.
Oh, it's okay.
We had people come in and pour the floor.
Oh, so you didn't actually use the plumb bob then, or any of these tools?
Yeah. So what does this have to do with anything? This is a nice distract.
So when you said you'd actually use them tools, you were just lying then.
This is
like somebody else used it.
Distract.
You watched
what
somebody
does this
else
have to
use
do?
the tool.
This is one of your tactics, is to distract.
To distract from knowing how much validity you have in what you're talking about.
To knowing that plumb lines are not parallel.
Well, so far, you know it because you've watched a man on thingy. Now, before...
No, I know it because I understand. I know it because I understand how the world works.
Okay, so before you watched this video, you already knew that plumb lines cannot be parallel. There are no two on your model,
yes,
of course.
Yes, I knew that. I knew that before the video, yes.
Okay, so geometrically...
Because I understand...
Did you know? Right, did you understand geometrically that beforehand, vertical and horizontal being perpendicular was going to be a bit of a problem?
I knew because I know that there's such a thing as gravity, and that plumb lines point to the center of the Earth, and therefore plumb lines at different points on the Earth will not be parallel. They will be radial from the center of the Earth. It's simple geometry.
Yeah. It doesn't seem to be mentioned anywhere anything about vertical, that though, does it?
It's simple geometry.
Anywhere Have you got any source anywhere, Brenda, that says anything
I don't
about
need a source.
vertical being to the center of anything, please?
I said plumb lines.
Yeah. Plumb lines is
plumb
what?
lines.
Yeah. What's the plumb line for? What's the plumb line
lines
do?
point. Stop interrupting me. Plumb lines point to the center of the Earth.
What are plumb lines, Brenda?
A plumb line is a string with a weight on the end.
Yeah. That establishes a vertical frame of reference, right?
It points to the center of the Earth.
It's not vertical, then. Do you not think it's vertical?
Vertical.
Yeah.
Is a direction straight from the center of the Earth. That's what vertical is.
Perpendicular to horizontal vertical, Brenda.
No.
Yeah.
Plumb lines point to the center of the Earth.
I don't think so. I don't think anywhere it says center.
Yeah, plumb lines point to the center of Earth.
Is that
because that's how gravity works?
Geometrical term, is it?
A center is a geometrical term.
Perpendicular to horizontal, Brenda. This is getting a bit boring, but I mean, I don't know. Are you trying to convince people that vertical isn't perpendicular to horizontal? Is that what you're saying?
Plumb lines are vertical. They're vertical because they point towards the center of the Earth.
Oh, they are vertical because they point to the center of the Earth.
Yes.
But they're also
perpendicular
to horizontal.
So a plumb line in North America, just a minute, listen to me. Try to listen. And please allow me to finish my sentence. A plumb line constructed in North America will point in a completely opposite direction from a plumb line constructed in Australia.
Can I give you one example, right? Now, I will go and stand at the North Pole, supposedly, with Polaris at my zenith. Okay? You understand that? And so that is my vertical is pointing straight up.
Do you understand that a plumb line in North America...
You can go to Ecuador, right? And then you stand and you have your vertical pointing up. Yeah,
and they will point in opposite in different directions.
So, would you be able to say quite confidently that my vertical was perpendicular to your vertical?
No, your vertical would be perpendicular to the point at which you are. And my plumb line in Ecuador will be perpendicular to the point where I'm at.
Yeah, but would you think that my vertical and your vertical would be perpendicular to each other?
Why would I think they're perpendicular? You mean parallel? I think you meant parallel.
Well, no. Listen, on your model...
You meant parallel. You must have meant parallel, right?
On your model, I'm stood at the North Pole. Yes?
So all of a sudden you can imagine yourself on a sphere, right?
I'm just checking with you.
All that stuff that half an hour before.
You just said before.
That was you. Brenda, just pulling bullshit, right?
You just said before, right, that they would be parallel.
So all of a sudden you can imagine yourself.
So how can you imagine that two verticals are parallel? What's up with you? You weren't thinking when you said that, were you?
They wouldn't be parallel, would they?
No. Well, they would
be. The vertical in Ecuador? No, they wouldn't be. No.
On your model.
In reality.
On your model.
In reality, they would not be parallel.
Yeah, they would. Of course they would.
No, they wouldn't.
Right. So on your model, I'm at the North Pole with Polaris at my zenith.
Which you are suddenly able to imagine yourself at the top of a sphere.
Yes. Oh, is that you imagine that's at the top of a sphere? Okay.
Yeah.
And then you are at Ecuador.
Yes.
And you have a vertical.
Yes, and my vertical points in an entirely different direction.
So what angular difference would there be between my vertical on your model and your vertical on your model?
I don't know what the degrees would be. That would be measured in degrees, right? The angular difference
angle
is measured
would,
in
yes.
degrees.
Yeah. What's up here?
Angular differences are measured in degrees. I don't know how many degrees difference that would be.
Right, but there, you are imagining there would be a difference between my vertical and your vertical.
Yeah, they would be different.
Yes, that's okay.
Yeah, that's reality. That's how it actually works.
Okay, but
and
because
that's how
you can say that confidently because
yes, I can.
You've seen a title of a YouTube video that says that.
No, that's not why.
Oh, okay, but that was what you give up as your proof of
no,
that.
that's not proof. It's my example.
Okay, so your proof
it's a demonstration. My demonstration is
your proof of this fact is
that's what we observe in reality, is that plumb lines are not parallel.
But you just admitted before you've never used a plumb line. So
no,
how do you know that it is observed, that it happens?
Because I understand how reality works.
Oh. You definitely sure. And your understanding stretches to geometry to understand angles and measurements of things. Okay, so you definitely understand geometry. And you definitely understand perpendiculars. And the fact that angles need two straight lines to be measured.
And gravity. I understand gravity.
Works in the vertical direction.
No, gravity establishes verticals.
Oh, brilliant. That's even better. Which is perpendicular to horizontal.
No.
Well, vertical is perpendicular to horizontal, isn't it?
No.
It's not.
Gravity establishes what is vertical locally.
Yeah. Which is perpendicular to horizontal.
So the vertical at the North Pole is entirely different than what's vertical in Ecuador. They're two different directions because of gravity. Gravity is what establishes what is vertical.
Well, yes, but only if you imagine you live on a ball with them two verticals be different. You have to imagine you live on something in order to imagine that verticals aren't perpendicular to horizontal.
But then if we measure them and they are not parallel, then we know that the Earth is curved.
Brilliant.
Because they're not parallel.
It will definitely have been measured by somebody who knows with the most accurate results possible, right?
It says done all the time by engineers, civil engineers, surveyors, all the time.
Brilliant.
Buildings and the supports for bridges point in different directions all the time.
Yeah. Nice.
Yeah, you're not being able to understand it doesn't mean it's ridiculous. So if the Earth is flat, then plumb lines would be parallel. We observe and measure that they are not parallel. Therefore, the Earth is not flat.
And Jeff, the Maine surveyor, is your main man. Step up, Jeff.
I just told you.
Well done.
I just told you. No, he's not the main man. He's just one example among many.
Any others?
I could cite another would be people have measured. There are these very long bridges. There are very long bridges.
No, Brenda.
There are very long bridges.
There are very long bridges that you do not know a thing about what you're talking about. I would prefer if you said another name and then I can start asking them, because it's obvious that you don't know what you're talking about. You obviously
yes, it's obvious I don't know what I'm talking about.
Because you've never touched the plumb bob or a level.
It doesn't matter.
Just watched people hold them.
Let's say what you say is true. I have it's not true, but let's say it's not. It is true. I've never touched a level. I've never touched a plumb bob. Let's say that's true. It's not true, but let's assume that it is. What difference does it make? What difference does it make, Bev?
What difference does it make
What difference does
that you're talking about something that you've never even practically done, as though you are an expert in it?
No, let's say that's true. Again, I have touched levels. I have touched plumb bobs. Okay. But let's say it's true. I have no experience with these things.
Yep.
So what? What does that mean?
You are talking about it as though you are an expert and you know all about this. You are.
I'm talking about... No, I'm not talking about it as if I'm an expert.
You are just saying that you deny Euclidean geometry. You say that surveyors do not measure levels because they have somehow a wandering horizontal that has to be checked every time they move their level. Every time, Brenda. Every time.
Bev, I'm not denying Euclidean geometry.
Yes, you are. You may not realize you are, not. But you are.
No, you don't understand Euclidean geometry.
Yeah, well, that's
at all.
Obvious, isn't it? Because saying that makes
yes, it is. Sense. Everybody understands it. That you don't understand these things.
Everybody understands that I don't understand it.
Correct.
Right. Okay. So you would know all about Euclidean geometry, wouldn't you?
So the point is that I don't have to have used a level or a plumb blob or a theodolite. I don't have to know anything about those.
You can imagine whatever you want, Brenda. Everyone knows
I don't have to have used those things
to imagine.
To understand to understand conceptually what's going on.
Really?
Really?
Yeah. How much have you ever looked into surveying?
Little to nothing.
Well, there you go. So how can you just imagine that you know all about it, and when you are especially imagining some sort of curve that you can't even geometrically describe?
I did, and I don't have to know everything about survey.
How did you geometrically
Could you not interrupt me,
because
please?
You just said I did.
Could you? No, I don't have to know everything about surveying.
No, you said you geometrically described the curve.
Could you stop interrupting me? Please allow me to finish a sentence.
Okay, well, I want to hear at the end of this how you geometrically describe the curve that you speak of. I'm
going to tell you that I don't have to know everything about theodolites and land surveying to understand the basic concepts involved.
It's not concepts, is it? Reality.
Yeah, no, it is. It's concepts. The concept of vertical.
Survey the land. Practically. Don't tell them it's a concept. People do this for a job, Brenda. You know nothing about it. Don't rubbish people's careers.
I'm not rubbishing their careers. You are.
You are saying that they do phenomenal things.
I'm saying
you are claiming that, Brenda.
I am saying that I don't have to be a surveyor or to understand theodolites to know and understand the basic concepts that we're talking about, that plumb lines are not parallel.
The concepts are there are plane surveyors that use tools. You know that, don't you? The plane surveyors.
That's not the concept. That's not the concept we're talking about.
Plane survey. You know that there are plane surveyors, right? And every surveyor you see with a tool, a theodolite, a level, a water level, anything, measuring tape, a measuring angle device, anyone that you see of that, they will be using Euclidean geometry. Now, in Euclidean geometry, triangles have 180 degrees internal angles. Right, Brenda? And horizontals are parallel.
On a sphere, they're not.
Are
on a
verticals. Sphere. Plane surveyors survey using Euclidean geometry on a plane, Brenda.
On a sphere, verticals are not parallel.
Yes. But there are no such things as verticals on the sphere as you imagine them.
The verticals are established by the force of gravity, which pulls the plumb bob straight
on
to the center of the Earth. On a sphere, yes.
Every sphere has its own gravity and its own verticals. Is that true,
Yes.
Brenda?
Every large, massive planet has its own verticals, yes.
Right, so you could show me that on any sphere, couldn't you? You could explain
No.
how... No?
No.
So when we look at a sphere, verticals at the top. Yeah?
It isn't the sphere which makes things vertical. It's the gravity.
And that acts vertically, which is perpendicular to horizontal?
Gravity doesn't act vertically. Gravity pulls things towards its center.
It's an effect.
Which establishes...
It's an effect.
Gravity determines what is vertical.
The effect determines what is vertical.
Gravity pulls the plumb bob,
Pulls
the plumb at the end of the line. Yes.
Gravity pulls things.
In this context, I'm using the word pull, yes.
Okay. So does it pull helium balloons away? In the opposite?
It pulls the air around the helium balloon, which lifts them. Buoyancy contains the word gravity in its definition.
And is it that bends the horizontal?
You don't know what you're talking about.
I do.
So gravity establishes...
I'm talking geometrically. And I can't see geometrically how you work your intersecting horizontals. It just doesn't work, Brenda. Plane surveyors couldn't do their job if that was how it worked. They would have to have a whole new method. It doesn't happen like that, Brenda.
No, they don't have to have a whole new method. They don't. You can use flat Euclidean geometry on planet Earth.
What's that?
Because
there's no such thing, Brenda, as flat Euclidean geometry. You've just added flat in there for some reason. Why did you do that? Are you obsessed with that word?
Does Euclidean geometry include circles?
Yes. Yeah.
Are circles flat?
It's axiom number 3.
Are circles flat?
If they're drawn on a plane.
Are circles flat?
Circles on a plane? Yeah.
Are they flat?
On a plane? I'm talking mathematically here, Brenda. I don't know whether
they're
you
circle, right?
Get to
they're
that
circular.
Extra level.
Are curved lines flat, Bev? Curved lines flat? Are curved lines flat?
Is that the mathematical description of flat?
Are curved lines flat?
We're talking geometrical here, right, Brenda?
Are curved lines flat?
We're talking geometrically, Brenda?
I'm just asking a question.
Yeah. I'm asking you,
are
you talking geometrically when you are talking about this curved line?
What do you imagine I'm talking about when I say the word curved line?
I don't know. That's why I'm asking.
You don't know what I'm talking about? You don't know what a curved line is?
Are you talking geometrically, Brenda?
What is a curved line?
What curve is it, Brenda?
What?
What curve, Brenda?
What?
What curve?
What's a curved line?
What sort of a curve?
What is a curved line?
What sort of a curve, Brenda?
It doesn't matter. Any curved line. Are they flat? Is a curved line flat?
Is it on a plane?
Any curved line.
Is it on a plane?
It doesn't have to be. It can be anywhere.
Okay.
It could be in...
I'm going to imagine a curved line on a plane. Okay, Brenda? And I'm going to tell you it's a curved line on a plane. Now,
Yeah,
you
is it
decipher
flat?
whatever you want. Don't bother
Is
asking
it
me
flat?
some stupid question containing a stupid
Is
word.
it flat? Is it flat? Is it flat? You can't understand it, can you?
Do you know
Is
what
a curved line?
Do you know what a plane is
think,
in mathematics, Brenda?
Is it flat?
Do you know what a plane
Is
is
a
in
curved
mathematics?
line flat?
Do you know
Is a
what
curved
a
line
plane is?
flat?
Do you not know what a plane is? Why are you asking me a silly question like that if you don't know what a plane is?
You know what a plane is?
You do know what
Is
a
it
plane is.
flat?
You do.
In Euclidean geometry, can you have a curved line
In
that is not
mathematics.
flat? Can you have a
check in the chat, Brenda, for 1 second, right? I'm going to read out for you. Now, in
I know what a
mathematics,
plane is.
A plane is a flat, two-dimensional surface that extends infinitely far.
I understand that. I understand third grade math.
So this curve that I'm imagining is on a plane.
Can you have a curve that isn't flat in any plane? Like a spiral or just a random curve?
Like a sphere? Like
No,
the
no, not a
surface
sphere.
of a sphere.
That
would
a spiral.
That would be a curve that is not flat in any plane, wouldn't it?
Correct.
Right. Okay.
Right,
So
correct.
you've just asked me, can I imagine it?
Euclidean. Yes. Is that Euclidean geometry? Are spheres in Euclidean geometry?
Yes. Yes. The last few
Well,
couple
there
of
you
books,
go. There's
Brenda.
the answer to the question.
Solid geometry.
Yeah, that's Euclidean, isn't it?
Yes. Euclidean.
Yes.
Solid geometry.
Yes.
4 pi r squared.
So when you were pretending,
you know that.
So when you were pretending not to understand how a curved surface, how plumb lines could be pointing different directions.
Brenda, you've done it again. You've just done it again.
You were pretending not to understand.
You've confused a ball with a thing that you're stood on, haven't you? The moment you added plumb lines to the sphere that we were talking about in Euclidean geometry, you made a pretty big mistake there. Could you see it? Did you spot it?
On a sphere. On a sphere.
Okay, spherical geometry then we're talking about.
Right.
Okay, spherical geometry.
Plumb line.
Okay, no, you can't do a plumb line on a spherical geometry.
Yes, you can.
No, you can't. It's just spherical geometry is the
can.
geometry of a two-dimensional surface of a sphere. 2 dimensions doesn't have a vertical component to it. Sorry, it doesn't.
No, a solid sphere does. A solid sphere in 3 space does.
Yeah, but that wouldn't have a vertical that is an extended radius line, would it? Because that'd be fucking ridiculous. Absolutely mental to imagine that you could put gravity on any sphere. Do you magic that?
Gravity.
Do you magic that? Is that an imagined?
Gravity is a force which pulls all objects to the center
of a sphere.
Of the mass. To the center of mass.
Right. So every sphere would do that then. Yeah.
On a planet, you'd have to be measurable. There's spheres where it would be too small to measure.
Spheres in reality then have a vertical and a horizontal, just like you do.
No.
They don't. Of course they do. Yeah.
No, they don't.
Yeah. The top would be the vertical component, and then the horizontal would go from side to side, just like any graph in Cartesian coordinates, right?
So this is where you're pretending not to understand this.
No,
you're pretending.
I'm just living in reality and describing reality, Brenda.
No, you're pretending not to understand. You're a Poe. Everybody understands that. You're a Poe. You're pretending not to understand this.
Sorry, Brenda?
What's what?
What did you call me?
A Poe.
What's that?
Look it up.
No. You just called me. What is it?
Yeah.
I'm here explaining reality to you, and to everybody else that's listening. I mean,
that's what you are, is somebody who pretends to be something they're not.
What am I pretending to be then, Brenda?
You're pretending not to understand. You're pretending not to understand these things.
You're saying I'm pretending to
like
not understand it, but that opposes somebody who's like pretending to be something that they're not. So you're saying I'm pretending to not understand it. So therefore, I must be pretending
right, because
to
you're
be
pretending, Bev. You're pretending, just like you pretended not to be able to imagine being on a sphere, and then when we brought it up later, all of a sudden you could imagine it. All of a sudden you could imagine being on a sphere.
I can be on a sphere.
For half an hour you couldn't.
Of course you can. You can stand on top of a sphere. I can imagine anybody standing on top of a sphere.
But before you couldn't.
I can't imagine anybody standing on the bottom of a sphere. That's fucking ridiculous, isn't it?
No, it's not ridiculous.
Yeah,
why would
it is.
Be ridiculous? Why would it be ridiculous?
What? Why? Somebody standing on the bottom of a sphere?
Yeah. Why is that ridiculous?
Well, I've just got to go and help the missus make a brew. You explain to people how you can imagine.
Run away. Go ahead and run away.
Run away to go to the kettle.
Hey, Brenda. You're a guy who's pretending to be a girl. How dare you?
No. I'm not.
I'm not. Dare you?
And you can show your bigotry and your prejudice. You can show your prejudice.
You're insane.
It's bigotry. It's bigotry and prejudice.
It's not bigotry. It's called chromosomes.
Yes, it is.
It's biology.
You don't understand biology.
Don't be calling Bev a
pretender. I can because Bev pretends. I'm not pretending anything. You can, that's just your bigotry and your prejudice. You are
the pretender.
Yes, I know. Your hyper-religious bigotry and prejudice.
No, it's not hyper-religious. You're
yes,
a
you
guy
are.
who says you're a girl. That's a pretender.
That's fine. You can believe that. You're welcome to believe that.
Don't be accusing Bev
of
being a pretender when you're the master pretender. Now,
I can.
You shouldn't go down that road. That's not the road you should go down. You should argue with facts. Now, what is a concept?
I am.
Let's go with a concept. What is a concept?
It's an idea.
Okay, so it's not reality.
Concepts are in your head. They're in your mind. Yes.
Right, and Bev is talking about reality.
Concepts describe reality, don't they?
When they go against reality, what do you call it?
How would you determine
when they go against reality? What do you call it?
I would call that imagination.
That's what your concept is. Then it's imagination.
Well, you'd have to show that, though. You'd have to show that.
It. What is gravity? You keep saying it's a force, and people smarter than you tell us it's not a force.
It can be considered as a force, yes.
But it's not a force. You can consider
it can be considered
reality.
One.
We're back to concepts.
No, that's not true. That's not how it works.
You live in the world of imaginations, and the one thing you should never do is call Bev a pretender. You're the biggest pretender.
No, Bev is, your moral outrage.
No, it's not moral outrage. Is that you don't throw rocks against glass houses when you live in the big one.
I don't live in a glass house. Mine is made of solid stone.
You're pretending to be something you're not.
Solid
that's
stone.
That's your moral outrage. That's your moral outrage.
No, that's not a moral outrage.
I don't
that's
care.
A biological fact.
I don't care about your moral outrage.
Biological fact. I don't care what.
No, it's not. It actually isn't.
But don't be calling someone else a pretender when you're the biggest pretender. Go somewhere else where you have some cowbell.
Yeah.
Okay,
Bev.
So what's a concept?
Bev is a pretender.
No,
Bev pretends to not understand geometry.
Brenda, let me ask one question and then you can have the mic back. You called Bev a Poe before, and what was the reason for calling him a Poe? Because you said he couldn't imagine standing on a sphere, and then he could imagine all of a sudden, right?
I think Bev is a Poe because I'm getting feeding.
Sorry, that's me.
Okay, I think Bev is a Poe because of his constant equivocation and avoiding of addressing issues, and then suddenly at a later time in the conversation, he can understand those issues.
Okay.
That's why I call him a Poe.
I'm just going to point out a hypocritical position that you're in now, and then I'm going to leave, and that's fine. You say that Bev's a Poe because he couldn't explain something, but then miraculously could later on. Yeah?
Yeah. Yeah.
So you know that gravity is not a force. And even though you can think of it as a force, that makes it conceptual only. But in the real world, it's an effect. And you push that it's a force anyway. I heard you repeat it many times. That makes you a Poe.
Gravity is a force. The fact that you don't understand this distinction, right, doesn't mean I don't understand it, right? Gravity can be conceived of as a force because it establishes a vector to objects, and anything that imparts acceleration to an object is a
Brenda,
force.
it doesn't establish a vector. It's an effect. The vector's already been established by Brenda. The vector's already been established by something else, and gravity is the thing that now suddenly starts moving. But it's not being pushed by gravity. Gravity is the thing that's already being pushed by something else. An effect.
Can an effect be a cause?
If it was an effect that was a cause, it would be defined like that, but it's not. It's defined as an effect. That doesn't mean that it's an effect that could be a cause.
Can an effect be a cause?
Ordinarily, perhaps. In this context of gravity, no, because it's defined expressly as an effect.
What kind of crazy question is that? An effect and a cause are two different words. They have separate meanings. What are you trying to say?
I just wanted to point out that you're being a Poe, Brenda, that's all.
If I use a cue ball to I use a cue stick to set the cue ball in motion. My striking the cue ball is the effect. The cue stick is the cause.
No,
but that doesn't mean
the cue stick is the cause. If the cue stick is sitting on the table without you holding it, ain't gonna push a cue ball. Are you insane?
Yeah, Brenda, in scientific method, the presumed cause, which would be the striking of the cue ball by the cue, is the thing that's manipulated by the researcher. So you've got to manipulate that cue to strike the ball, otherwise it's not the cause in scientific method. But you can think of it as an effect if you want to, but that doesn't make it reality. That just makes it in your mind.
So if I cause the cue stick to move and to strike the cue ball, right? That's cause and effect, right?
Right, you caused it.
Right. So I caused the cue stick to strike the cue ball and to set it in motion.
You caused it.
So that would be the
motion. So the motion of the cue ball is the effect, right?
Correct.
Can the cue ball then strike another ball and set it in motion?
But that's not how gravity is defined.
Then, in that case, the cue ball is the cause, and it's striking, say, the 6 ball is the effect.
That's not how gravity is defined, Brenda.
That's how it works.
Gravity is expressly defined as an effect. That doesn't mean it's a consequential cause. It's an effect, Brenda. It's the end of the line. It's the ball moving because something struck the cue ball, and it was you, because you picked up the cue and you struck the cue ball, and the cue ball started to move. So gravity is the moving of the cue ball, and you need something to hit it or push it, but you haven't got anything on your model.
Nothing. It's like a domino. You got secondary, tertiary causes, but the first cause, that's what we're looking for, Brenda, is the first cause.
No, we're not. I'm not looking for the first cause. I'm just using a gravity to explain.
Well, then you don't have
You said it. You said gravity is an effect.
Stop over talking me. You cannot have an effect without a cause. Would you agree with that?
You said.
Would you agree with that?
Sure. I'll accept that.
So then you agree that cause precedes an effect.
Sure.
Okay. So if I set up a bunch of dominoes and one's going to fall on the other and on and on and on, then the second and third and fourth have an effect on the fifth. But who has to start it?
That's not what we're talking about here.
No, that's what you used as a silly example of a ball hitting another ball and hitting off the corner of a table. But we're looking for cause and effect, and you have not established that.
You said gravity is an effect, isn't it?
No, I didn't say that.
Well,
Sleeping
Anthony said it
Warrior
was.
taught. I am tearing apart your weak argument to Sleeping Warrior, saying to you that you're describing in effect with the word gravity. Now, gravity is what, according to someone smarter than you, named George Muser? What is it?
So I'm talking.
What is it?
What is what?
What did George Muser say gravity was?
It's the bending of space-time.
No. What did he say it was? You can think of it as a force if you want to.
Yes.
But it's not. Hang on. Let's finish it. But it's not a force.
And what is the rest of it?
When you pick
the rest of it is that you can
it isn't.
Is that it is a force.
You caused it.
I caused what?
You pick up something and drop it. You're the cause of it. It's going back to equilibrium.
No.
This is so simple.
No, I'm not the cause.
Okay, let me ask you something. There's a rock in front of your house by the door. Wherever you live, there's a rock in front of your house by a door. It's been sitting there for 5 years undisturbed. You pick it up. What caused it?
What caused what?
Picking it up.
What caused what?
If you pick it up, if it moves, if it's been there undisturbed for say 5 years, and then you pick it up, what caused it to move?
I caused it to move by exerting a force.
That's
but if no, it doesn't. If I let it go,
it's sitting there
if I let it, no, it doesn't.
It's resting. It's happy where it's at. It's not falling. It's not being pulled. It's not being pushed. It's just sitting there, happy as a dog. And then you pick it up, you disturb it, and you let it go. And guess what? It's going to fall down right next to you.
Maybe letting it go.
Maybe
letting it go.
Spot, maybe
do I get to talk in this scenario or not?
Yeah. After you stop interrupting me in the middle of my sentence, maybe. Everything you said has to do with the imagination and concept.
No, can I speak now?
I'm not done. I will tell you when it's over. You said words. I listened. You kept saying to Bev, concept. We're looking for reality. Now, if you look up the word concept, it's a thought experiment. It's an imagination. It's something in your mind. We are looking for reality. And Bev was describing reality, and you called him a Poe. And that's when I got upset at you for calling him a Poe, for pretending to be something that you thought he wasn't when you're the one doing it.
Yeah, your moral outrage and bigotry and prejudice doesn't matter.
Listen, if you're going to go there, I'm done with you, because I don't care if you think you're a dog. I really don't. The point is, you are a pretender clown calling someone else who's in reality.
Your moral outrage doesn't matter. I don't care about your moral outrage.
You can think you're a dog. I can care less. I don't have
fine.
no more. Why you keep interrupting me?
Well, when do I get to talk? When do I get to respond to your claims?
Stop interrupting, you might get to talk.
Well, it's been 5 minutes. When do I get to talk?
Well, you've been interrupting for 5 minutes.
You don't really, Brenda.
No, but when do I get to talk?
You don't.
Okay,
I want to respond to him.
On. You get to talk. Bev is back. Bev, I hand it back.
No. You carry on, 10th. I mean,
Well, I'm trying to tell Brenda that if she wants to pretend to be a dog, a tree, I can care less. It's not a moral outrage. The outrage I had, excuse me, Brenda. I'm in the middle of trying to explain my outrage. Please don't interrupt now it
is moral outrage.
Don't interrupt my outrage as I'm trying to explain what the outrage is about. The outrage wasn't about you pretending or what you think it was. Moral outrage, as you said, religiously. I can care less if you think you're a rock or a dog or a bird. That's up to you. That's
you obviously do care.
Brenda.
No, I don't care. You
obviously do.
Will you stop interrupting? The reason I interjected at all was because you said Bev was pretending.
Yes.
That's when I objected.
Yes.
Now let me finish.
Yes.
Let me finish. I don't care if you want to think you're this or that or the other. That's between you and the Creator. I don't care. I don't lose any sleep.
Well, that's not true.
Let me finish. I do not lose. Why are you constantly interrupting?
Because you're just constantly talking, and I'm waiting to answer, and you don't let me.
You misdiagnosed me. I'm trying to clear the air. My outrage is not what you think it is. So let me explain what it is. The hypocrisy of you saying that Bev was a Poe is why I entered in the conversation at all. That was my outrage. The biggest pretender of all. Okay? That's why I entered. Not because it's moral, not because it's religious. I can care less. You can be whatever
Well, you're
you want.
wrong.
So please, no, quit. I'm trying to tell you why I entered the fray.
Well,
and
you
did. You keep wanting.
Do I get to talk yet?
Oh my goodness. I'm trying to state that your description of my outrage is wrong. Will you let me finish?
I understood it 10 minutes ago.
No, you didn't. You've been repeating it as a moral, religious outrage, and you're wrong.
Yes, it is.
No, you're wrong. So how could you understand it when I'm telling you you're wrong?
Mm-hmm. You think I'm hypocritical.
Look,
you think I'm hypocritical because you don't think it's legitimate for somebody to say that they're transgender.
No.
You don't think that's legitimate.
No.
That's not based on reality. That's based on your religious beliefs.
Misunderstanding, Brenda.
Listen, please. I have a family member who is transgender. I know a lot about
I feel sorry for her.
Yeah, well, listen. I know this topic quite well. I've done my hours.
Well, I would like you to tell your friend. I'd like you to tell your friend. Well, you never let me talk. Because you never let me talk.
No, you won't let me finish a sentence before I'm done, and you want to talk? Are you nuts? I'm done with you, Brenda. You're insane. Bev, take over.
Yeah.
Good riddance.
I don't know what you think you're going to be ending up saying here, Brenda, because you've not really got much to say. Have you?
I'm going to complete what we were talking about.
No.
Which
what were we talking about? Because I've forgotten.
Do I get to talk or not?
No, I don't know what you're talking about.
Do I get to talk or not?
Not really. No. I don't
well, you came into the middle of it. You came into the middle of it. You don't know what it's about.
Brenda.
So be quiet.
You came into this.
Be quiet.
Server.
No, you came in. You came in just now.
Here before.
You were gone. And now you came in.
What were you
don't know the discussion. You don't know. You don't know, do you? So shut up.
And I'm
sit down
asking
and
you
zip your mouth.
What it is you are saying.
Zip it.
No, Brenda,
zip it.
Brenda, who are you talking to?
So I want to complete what I was talking about, which is
what are you talking about? I was saying recap, please. It's been a while, hasn't it?
We were talking about gravity and whether it can be a cause or an effect. An effect
that was
can be. No, that's not true. Then a billiard ball can't impact another billiard ball, which can impact another billiard ball.
Sorry.
Okay, so Brenda, Bev, just give me one sec.
Yeah.
So when you finished with the billiard balls and you get to the final billiard ball, and the final billiard ball then moves, that last moving billiard ball would be the effect. All the other ones prior would be all primary, secondary causes, right?
No,
yeah.
No.
It would.
No.
So where would the effect
it's a chain. It's a chain of cause and effect. Every billiard ball causes is an effect and a cause. Things can be an effect and a cause. Yes, they can.
So if you hit billiard ball 1 with your cube, the cause is you hitting the billiard ball with your cube.
Right.
If that ball then hits another ball, the cause of hitting the other ball is the first billiard ball that you've already hit.
No, it's not. No. The cause is the first billiard ball hitting the second one.
That's what I said.
And the third billiard ball hitting the fourth one. Mm-hmm. The cause is the third billiard ball. They're simultaneously cause and effect.
No, they're not. Cause is something that.
Yes, they are.
No, Brenda,
you can have a causal chain. It's called a causal chain. It's a chain of cause and effect.
Brenda, the key word is the causal chain, right? We don't have an effectal chain, do we? It's either causal chain or it's an effect.
No, each billiard ball becomes simultaneously the cause of succeeding events and the effect of preceding events.
No, because all the causes of all the previous billiard balls, all hitting all the other billiard balls, they are all causes, right? And the effect
they're
is
causes
only...
and effects.
So, Brenda, listen. When billiard ball 1 hits billiard ball 2, the cause of hitting billiard ball 2 is the first ball, right? And when 2 hits 3, the cause of 3 moving is 2's hit it. And then same for 4, 3's hit it. And then 5, 4's
You
hit
got
it.
it.
Right?
Yeah, that's a causal chain. It's a cause of each cause becomes and affects a change in a subsequent ball, which then becomes the cause of additional effects.
But Brenda, listen, the problem is the definition of gravity. The definition of gravity describes gravity as the effect. So it's not part of a causal chain, it's the result of the causal chain.
No, it can be gravity can cause other. It can be an effect, and then it can cause.
No, it can't. No, otherwise, it would be a cause.
It can do both.
It can't. Otherwise, it would be considered a cause and effect, and it's not. It's considered an effect, and that's the last one.
An effect can be a cause.
It can't. An effect is the result. So, like, the effect of catching a cold is coughs and sneezes, but coughs and sneezes are not the cause. They're the effect. That would be gravity. The coughs and sneezes being spread through sneezes and whatever, that's the cause of spreading it. That would be not gravity.
If billiard ball 3 is moving, the cause is billiard ball 2, right?
Correct.
Then billiard ball 3 causes billiard ball 4 to move. So billiard ball 3 is both an effect and a cause.
So where's the gravity in it then? Because there is no... You have to identify...
So gravity can be both a cause and an effect.
No, you have to identify the effect. So if billiard ball 2 hits 3, 3 hits 4, and 4 hits 5, please identify the effect.
It depends. So if I'm in the middle of that chain, the cause of billiard ball 3 moving is billiard ball 2. The cause of billiard ball 4 moving is billiard ball 3.
But I
asked billiard ball 3
I asked you to identify the
can
effect.
be both a cause and an effect.
No, because the minute you say it's an effect, that's the end of the chain, Brenda. Otherwise, it's still a cause.
It's not the end of a chain.
It is, because you need to identify where the effect is, and there's only one place the effect is, Brenda, and it's at the end.
No, that's not true.
Okay, so if ball 1 hits ball 2 and ball 2 hits ball 3, where is the effect? Tell me the effect.
It's in the middle.
No, go on then, quantify it. Where is it?
So ball 2 hits ball 3. That causes ball 3 to move, which causes it to strike ball 4.
No, ball 4's not in it. Ball 4's not in it.
Yes.
No, there's no ball 4.
Ball 3 is affected by ball 2, but it causes affected. Ball 4.
No. Ball 3 is affected, not effected, affected. So ball 3 is affected by ball 2, but that doesn't make it the effect. It's affected by something else. You're correct, but it's not the effect. There's only one effect, and it's the end of the chain. Everything else is causal, and you can say they're effects if you want to, provided that's the end of the chain. But if it's not the end of the chain, Brenda, the effect becomes the end of the chain at the end. That's why gravity is an effect, and it's not a cause.
That's just nonsense. Causal
no, you don't understand cause and effect.
Causal
Brenda, you don't understand cause and... Right, Brenda, let's change it so it's slightly different.
You're just using words to try to define things. But in a causal chain, each cause can become a subsequent effect, which then becomes a cause of further effects. It's cause and effect, cause and effect, cause and effect.
Yeah, but what you're trying to do is say that there are 3 or 4 different effects in the middle of the chain. No.
Yes.
The effect is the end of the chain. Otherwise, it wouldn't be the effect. It would be a cause of something else.
But there is no end of the chain.
Yeah, there is. There's only a finite number of balls.
No, there isn't.
Yeah, there's not a ball 5. We said there wasn't a ball 5.
Time keeps on moving. Time is always moving. So there's a continuous amount of change in the world. Everything is always changing. So there's no end.
There's not a 5th. So we know that we can identify where the causes are, and we can say which one's the effect. Now, if you're going to say that the effect is between 2 and 3, and the effect is ball 2 moves because it's hit by ball 1, but it hits ball 3 and it starts somewhere else, I'm going to say no, that's another cause.
You're just wrong, and you're just trying to define reality by using words.
Then you don't understand cause and effect relationships. And that explains an awful lot.
I do understand them.
Brenda, if you've got 4 balls, but you haven't got a 5th ball, the only effect would be the end of the chain, because everything else is a previous cause. Otherwise, there would be no end. It would be continuous.
That's how the world works.
But there's only 4 balls. There's not a 5th ball, so there is an end.
No, it doesn't end. It just keeps on moving forever, right?
There's only 4. Right. So if it keeps on moving forever but doesn't hit another ball, that movement forever. Listen, Brenda, if it keeps moving but doesn't hit another ball, that movement forever would be gravity, that continuous movement forever, because that's the effect.
No, so it could move in a straight line. You accept Newton's basic laws. It would move in a straight line forever. It could move for a million years.
Away from the point. Now you're moving away because you don't want to concede. If that last ball doesn't hit anything else, that then becomes the effect. The moment it hits somewhere else, that moment, that interaction, that then becomes what was previously an effect, is now the cause of the new thing that's happened, and that's all it is.
Right. Yeah. So you're admitting that it never ends. The causal chain never ends.
No, I'm saying that there is an end.
Yes, you are.
That end is the effect.
But there is no ending to it because everything moves.
So when Newton's apple falls from the tree, right, and you guys say gravity pulls it, right, and we know gravity is defined and we know what causes it, we know that it's not being pulled by anything because we know gravity is defined as an effect, and it's the effect caused by uneven distribution of mass. That's what Einstein says.
If gravity is an effect, it can't cause anything to move, can it?
Correct. So what makes the apple move?
Gravity.
But you just said it can't make the apple move.
Well, according to you.
No,
but it does. It does.
According to Einstein, the current position in physics, physics.
No, you don't understand physics. You don't understand elementary math.
Brenda, you've said you don't understand too many times.
Yeah, you don't.
Emma's not even in this room because you're in here. Just keep obfuscating the point all the time.
So the point is...
What is the point? You don't think you have a point here?
The point is that gravity causes objects to move.
It doesn't, Brenda. It can't cause objects to move. It's an effect.
But they move. Therefore, it does.
So what causes them to move? A push or a pull. But it ain't gravity doing it because gravity is the effect of it moving. In other words, the apple's falling.
Then what causes them to move?
No. That's what we're asking. That's our question. You're supposed to know all the answers, though, right?
It's gravity.
It isn't. Gravity is the effect.
If something falls, Brenda, it's because I've picked it up and dropped it. Therefore, the cause was me actually dropping it. Yeah, if I don't let go, Brenda, it doesn't fall.
But if you let go, you're not causing the rock.
My hand releasing it is the cause of it falling.
That doesn't cause things. That doesn't cause things to move.
Your problem is if he picks it up and lets go of it and it starts to fall. And now let's remember that helium balloons fall to the clouds, right? Whichever way it falls, when it's in movement, that movement, by definition, according to Einstein, your current physics, that movement is the effect of gravity, right? The movement. But you need a force to make it move because Newton's first law, and listen, Newton's first and second law require a moving accelerating object to be pushed or pulled because that's the F equals ma. So what force is doing it?
The force of gravity.
No, it's an effect, Brenda.
Yeah, but it can be considered
an effect.
But it can be considered to be a force.
Only in your head.
Oh, in reality, it can be treated as a force.
If it's Brenda. If it's an effect, it's the end of the chain, right?
So then it can't cause. So then it can't cause things to move, can it?
Correct. So what makes the apple move? We're back to square one.
Gravity does.
It can't make things move.
Yeah, but nevertheless, it does, right?
But it can't. You can't make something that can't do something. Do something.
Yeah, so there's a problem here, and the problem.
Yeah, you're right. You're right.
Yes,
welcome to Flat Earth, Brenda. There is a problem. Welcome to Flat Earth.
Right. No, but the problem is your arbitrary definition and declaration that gravity can't cause anything to move.
But Brenda, it's not my definition, it's Einstein's.
It's not. You don't understand Einsteinian gravity at all.
Can you define Einsteinian gravity for us so that we know that you at least know the definition?
So it's the bending of space-time.
No. Try again.
No? What is it then?
That's not the definition. Do it again.
No, tell me. I don't know then.
It's the effect of the curvature of space-time caused by the uneven distribution of mass.
Yeah, and causes can have further effects, can't they?
Yeah, bending space-time. So how did the apple
and then
move?
an effect, because the effect of gravity caused the apple to move. Just like
Effect
the
of
third
gravity
billiard
can't
ball.
cause the apple to move, Brenda. It's an effect. You don't understand cause and effect. When you said
Effects.
before, Brenda, when you said before that we have a problem here with the definition, right? You attributed it to me, and I said, no, it's Einstein's. You're right. We do have a problem, and it is the definition. You're absolutely right. It's not my definition. It's Einstein's. But you know what? It fucks your model because you can't make apples move with an effect because the apple moving is the effect, but you need something to push it according to Newton's first and second law. So what is it that pushes it or pulls it?
Gravity does, because causes,
Effect.
because
That's the
effects,
effect.
because effects can be causes. As
They
you
can, but they're not
demonstrated
effects.
with the billiard balls, with the
The minute
billiard
an
balls,
effect
you
becomes a
admitted
cause,
you
the minute
admitted
an
that
effect-
effects can be a cause.
Brenda, the minute an effect becomes a cause, it's no longer an effect, and we know gravity is the effect of the curvature of space-time. So what makes the apple move?
The gravity does, because
No,
gravity.
it can't do that. It's an effect.
Why not? Why not?
Because Einstein defined it and it fucks your model. It's not my problem you don't like it, but you need to make it a force. But it's not. It's defined as an effect, Brenda. Welcome to Flat Earth.
So if the movement of billiard ball 3 hits it, the movement of billiard ball 3 is an effect of it being impacted by billiard ball 2. According to you, then billiard ball 3 cannot cause billiard ball 4 to move.
No. The minute billiard ball 4 is introduced, and if number 3 hits it, that then becomes what was previously an effect, then becomes a cause. But remember, we haven't got a 5th billiard ball. We're stopped at 4.
Yes,
so
we
if
do.
Billiard ball, no, we don't. We've stopped it at 4 because there's a finite number of balls, and we're not going on forever. We're not having an
There's
infinite
a-
regress.
There's an addition, we have an additional mass in the gravitational effect. That additional mass then becomes the effect of gravity.
Yeah. So it's moving. So what's
Yeah.
caused it? Was it the previous billiard ball, or was it something else?
The gravity caused it to move.
No, gravity's the effect, Brenda. So if we haven't
Yeah.
got a 5th ball and we've only got a 4th ball, and let's say it had perpetual motion and Newton's first law applied on Earth, that it could continue on without, it would carry on in a constant direction at a constant velocity unless acted upon by a force, right? Let's just say it carried on forever. That would be the effect of gravity, the continuing movement of that ball, because it hasn't got another ball to hit, right? That's the effect of gravity. But it's moving, and it was hit by a previous ball. That previous contact with the previous ball is the cause. Otherwise, it wouldn't be moving, because you need a force to make something move. But when that object's moving, and there's not another ball for it to hit, right? That then becomes the effect. And we that's the definition. But you need a force to make something happen. So what makes the apple move?
But effects can become causes.
You're
And
right,
gravity
but then-
gravity is an effect, and it can become a cause.
Right, but then there's no effect. So you need to identify the effect. So
Well, the effect would be the object moving.
right, that's the effect, right? So there would be the gravity, right? But what makes
Right.
the apple move?
The gravity did. The gravity became the
gravity's
cause of it moving.
The apple's gravity's the apple
The gravity,
moving. Brenda, but what-
gravity is the apple moving. That's not gravity. Gravity is an effect.
That's the
Gravity
definition.
is an
Oh,
effect.
watch out, Tony.
How
Yeah,
can
that's right. So the apple moving is the effect. But what made the apple move, Brenda?
the cause was gravity. Gravity
No,
became
it
the
wasn't.
cause.
Gravity's
of
the
the apple
effect.
moving.
Brenda, gravity can't do that.
Effects
It's an
can
effect.
become cause. Effects can become causes.
But then they're not effects anymore. But we know gravity is the effect. So it has to be the movement is the gravity. But what makes it move?
If billiard ball 3 becomes the cause of billiard ball 4 moving, it
Yeah.
doesn't cease to exist because it's now a cause instead of an effect.
I didn't say it did. That's a straw man. If billiard ball 3 hits billiard ball 4 and 4 starts moving, that movement is gravity according to the definition by Einstein. Not my definition, Einstein's definition. However, we have the effect, but we have a ball that hit it. But when the apple falls from the tree, Brenda, we haven't got anything contacting it. It moves all by itself, but no forces, because the effect of gravity is it moving.
It moves because gravity is causing it to move.
No, it's not. It's an effect.
Because effects can be causes.
It can't cause the apple to move. It's the effect.
Effects can cause things.
But then it's not an effect anymore, and we know gravity is the effect by definition.
That's not true.
So if billiard ball 2 hits 3 and 3 starts moving, but there was a billiard ball that hit it, we know that billiard ball 2 was the cause. But you can't have billiard ball 3 start moving when nothing's hit it, because you need a contact, don't you? You need a force to push it or pull. So we have the apple falling from the tree for some magical reason, and we know by definition the effect of the curvature of space-time caused by the uneven distribution of mass is gravity. So we know that the apple's moving, and the effect of gravity is the acceleration of the apple, but something's got to make it move. You need a force, and you can't have a force and an effect because then you haven't got an effect. So we know the effect is gravity. We see the apple move. What makes it move?
Effects can become causes. As you said, in the billiard ball.
Brenda, then they're not effects anymore. Brenda, they're not effects anymore if they become... They're not.
They can be simultaneously caused. They can be simultaneously considered to be cause and effect. It depends.
Brenda, you're conflating cause and effect because you need to do that for your model. No, I'm not. But yeah, you are.
It's just
Everybody can see it, Brenda.
It's just a point of view. It's just a point of view.
Definitions and words have got meanings, and Einstein defines them for us to stop idiots like you telling us that forces can be effects. They can't. They're different.
Why can't they?
Because they're different. You can't make the apple move without a force. So you need a force, and we know the effect is gravity by definition of Einstein. So what makes the apple move? Don't say gravity.
Gravity does, because
it can't. It's an effect.
Brenda, effects can be causes. Effects and effect can be a cause.
Brenda, if I asked a 5-year-old what makes the apple fall from a tree, 9 times out of 10 he's going to say it gets too big for the stalk and the stalk snaps. Why is that not the answer?
Because we don't think in terms of 5-year-olds, and a 5-year-old would understand that gravity makes the apple fall. That's what a 5-year-old would understand.
No, gravity doesn't know. Yeah, right. A 5-year-old will think that because he gets indoctrinated by teachers that have been told that Einstein says that gravity is an effect. But in the national curriculum, they have to teach that, right? That don't make it true. Einstein's your current citation.
That's true.
And gravity is the apple falling. But we know that you need a force to make it fall, right? And we can explain it with relative density, but you can't explain it without gravity being a force. And it's not a force, is it? It's an effect. So you're fucked, Brenda. You just don't like it.
You can't explain it with specific gravity. That doesn't explain
specific gravity. I didn't say specific gravity.
You said relative density. Relative density is specific gravity.
No, I said relative density disequilibrium. It's a new term that doesn't previously exist.
No, it means specific gravity. That's what it means.
No, that's what you think it means, but that's not what I say it means.
That's the definition. What I say.
The point is, Brenda, I can explain it. Brenda, I can explain it with relative density disequilibrium. You can't explain it.
You can't explain it because
it's just more dense than its medium.
Density isn't a force.
You're right. You're right. It's a scalar. I never said density. I said relative density disequilibrium. Specifically, 3 words, not 1. She gone?
She's gone. She's dropped.
Was she kicked?
Yeah, it might have been kicked.
Who by?
Emma.
Emma?
Yeah.
Emma, did you kick her?
She's in the other room.
That's what she said by vote. Oh, right. Oh, no, that was you. Who put that?
She called him a Poe.